Alrighty, let's take a look at question 2. In question 2, we're going to be taking a look at the interaction between the average rate of change and the instantaneous rate of change. Alright, so problem 2 is as follows. We're to find the x value in the interval 1, 4, where the instantaneous rate of change, or the IROC, instantaneous rate of change of f of x is equal to the average rate of change, the AROC, of f of x, of course, on that interval 1, 4. Okay? All right. So we want to find the x value that where if you have the derivative or the instantaneous rate of change of f on that interval is going to be equal to the average rate of change, where the function is x to the third plus 2x. Okay, all right, let's go ahead and do it. So what we're going to do first is go over the formulas and definitions for instantaneous rate of change and average rate of change. Okay, so you have to remember that the instantaneous rate of change, or IROC, is also referred to as the rate of change, and that is basically the derivative at a particular x value. The average rate of change of a function on an interval AB is the slope of the secant line, which is f of b minus f of a divided by b minus a. So the task here is we want to find the x value, where the f prime of x is equal to f of b minus f of a over b minus a. That basically satisfies the conclusion of the MVT, the mean value theorem. Alrighty, so let's get started. What we're going to do is break the problem into 3 parts. We'll find the rate of change, the average rate of change, and then see what x value makes them equal. Alrighty, so part 1, let's find the instantaneous rate of change, or rate of change. They mean exactly the same thing, okay? So we have the function f of x equals x to the third plus 2x. The instantaneous rate of change is the derivative, so we apply the power rule here, and that gives us 3x squared plus 2. Alrighty, so we're done finding the rate of change. Step 2, we're going to find the average rate of change. Okay, so remember the rate of change is the slope of the tangent line, the SOT. But the average rate of change is the slope of the secant line. So that's what we're doing right now, all right? So we want to find the average rate of change on that interval. So we have the interval 1, 4. The smaller of the two is a, which is 1, and then b is 4. We need f of b, which is f of 4, so plug that into the function. What's the function? The function is x to the third plus 2x. So if you plug in 4, you have 4 to the third power plus 2 times 4. All right, apply your order of operations here. You have 64 plus 8, which is equal to 72. All right, that's f of b, or y2. Then f of a, or y1, is f of 1. So that's, you plug in 1 into the function, you have 1 to the third plus 2 times 1. And that equals 3. Okay, all right, so the average rate of change is going to be as follows. So the average rate of change is going to be f of b minus f of a. Let's just write it again so we don't get confused, over b minus a. Okay, all right, so that's going to be f of b is 72 minus 3 divided by b minus a, which is 4 minus 1. So that's going to give us 69 over 3, which is equal to 23. Okay? All right, so now the last part is we want to find the x where they're both equal, okay? Where IROC is equal to AROC. That's what we're gonna do now. All right, so let's go ahead and set them equal to each other. So IROC is a quadratic binomial, 3x squared plus 2, and AROC is the numerical value 23. All right, so let's just solve this quadratic equation for x. Subtract 2 from both sides. 3x squared equals 21. Divide by 3. X squared equals 21 over 3, which is equal to 7. And then you just take the square root of both sides. X is plus or minus root 7. We are considering the value that's between 1 and 4. So we're going to take the positive one. So x is equal to root 7 is the one that satisfies the condition of being in the interval 1 to 4. All right, so this is the x value where your slope of the slope of the secant line and slope of the tangent line are the same. Basically, our tangent line and thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming AP Calculus exam, do give us a like or a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about what we covered in this tutorial or any calculus questions in general, just post it in the comment section below and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to other great AP Calc tutorials such as this. More support resources can be found at our website at mathgotserved.com. Do check it out or take a look on the link in the description below to get more tutorials. Thanks again for watching and have a wonderful day.